Hi everyone, my name's Charlotte Willans and this project involves using robotics to remove the harmful effects of toxic metals in industrially relevant processes. And the project is also supervised by colleagues in chemistry, Ian Fairlamb, and also in physics, Lawrence Wilson. So within our group, we've developed an automated platform that uses the electrochemical synthesis of metal complexes for catalysis. So in the electrochemical synthesis, we start with a ligand precursor. When we apply a current, it gets reduced at the cathode to form our coordinating ligand. We use a sacrificial metal anode, which oxidizes and releases ions into solution. And in solution, the two come together to form our metal complex. And as you can see, the process is very atom efficient because hydrogen is the only byproduct. This is an example of the types of complexes, so these nickel complexes for catalysis, that we might make in this project. But because hydrogen is the only byproduct in this reaction, it means that we don't need a workup step and we can directly flow from the catalysis reactor from the electrochemical reactor into the catalysis reactor. And as part of our platform, we also have online analysis, which enables us to monitor the processes and then feed back to optimize these processes. This is an example of the type of reaction that we might study in our catalysis reaction, so a Suzuki-Mayura reaction, which is used widely in industry and currently relies on palladium. So moving to base metals for these types of reactions has advantages. However, there are still disadvantages to using nickel. So for example, nickel in the metallic form, so the plate that we have in our electrochemical reactor to start with is non-toxic, but the compounds that we form for catalysis are highly toxic. And this is one of the challenges that we aim to address as part of this project. So one of the challenges of using homogeneous metal catalysis is it's very difficult to separate the metal from the other materials downstream. This means that metals are often not reused, which means that the processes are highly costly, both from an economical point of view, but also it has huge environmental impact. So the mining, the transportation, the use, the removal of these metals has huge environmental impact, and also issues with toxic contamination downstream. So this project will address this by adding a further step to the automated flow platform. So this is another electrochemical step. So here our metal species are electrochemically generated through oxidation. Here we aim to recover our metal species through reduction. So we're reducing our metal onto a plate, which enables its recovery and reuse. So this means that the metal can be reused. It's going to significantly reduce the cost, both environmental and monetary cost of using those metals. And it can be done locally. So we can go directly from this step, we can move it back to this step, and the metal can remain locally on site. And also because this is a closed loop system where we're generating our toxic metal species, there's a much lower risk of people handling these materials. So also there's a much lower toxic risk of using these metals. So thank you for listening, and if there are any questions, I'd be happy to answer any.